Okay, so in this question, they have essentially given us two alternating voltage sources, right? They have given one voltage source to be 30 volts with a phase of 0, and then they have mentioned another voltage source, V of x, which we have to find, right? Another thing they have mentioned in the question is they're telling that the current which is going to be passing through this circular element is equals to 0, right? Now, if there is no current passing between two nodes, what does that essentially imply? That essentially implies to us that the potential difference is 0, or that V1 and V2 have the same potential, right? Because otherwise, if V2 had more potential than V1, then current would be passing from V2 to V1, and consequently V1 had more potential, it's going to be passing from a high potential V1 to a low potential V2. But if they have the same potential, obviously there wouldn't be any current between the two nodes, right? So when they say there's no current passing to this element, they're essentially implying V1 equals V2. Yeah, and we will be using standard nodal analysis to solve this. So this is first of all, you assume the direction of the current. We assume the direction of current is going away from the node, so we assume these two cases. And since there's no current passing to this section, I can ignore it, or for now I can mention one of the current directions and we'll figure it out later on. But at node 1, what is essentially happening now is we will first consider this section. Since V1 is at a higher potential, you do V1 first, then you subtract it with 30, phase of 0, you divide it by the resistor 5, right? And this whole thing is going to be negative because it's leaving the node, right? Similar way, we have negative of V1. You treat inductance the same way you would have treated resistance. Inductance and resistance are treated the same way. You divide resistance or you divide inductance, yeah. And the third case, obviously we can ignore it altogether. We assume, in this case we're assuming V1 has a high potential, so V1 is first, subtract it by V2 and divide it by 2 plus 5 of J, circuital element. But we know that this current is equal to 0, so we can ignore this, yeah. And this whole thing is going to be equals to 0. Now, one thing to now we can first try simplifying this. This will be 0.2 V1. This is going to be 6. You can ignore the phase of 0. If it was any other thing, we could have considered it, but since it's phase of 0, we can entirely ignore it for the moment. Now, if you have this section again, now we can convert this. Now, in your calculator, press on the shift button and press on the plus button at the same time, right? And then it will open something called as pole in your display. You'll first have to enter the real part, which is 0 in this case, and then you'll have to enter the imaginary part, which is 5. And when you enter this, this will essentially give a rectangular form in polar form, and in polar form this is basically 5 of 90 degrees, yeah. So when I convert this rectangular form into polar form, I basically get V1 divided by, and this is plus by the way, this is V1 divided by 5 angle of 90, right? And this is equals to 0. Now, to simplify this, we can bring negative 6 this side. When you bring 90 up, right, this is going to be negative 90. So that's one thing, one important thing you can remember. When you take V1 common now, it's basically going to be minus 0.2 minus 0.2. Since it divides 1 by 5, it's going to be zero point 0.2 again, and since this has gone up, this is going to be negative 90, right? The whole thing is equals to V1. Now you can go to mode and go to complex mode in your calculator, right? And in your complex mode, enter this whole section and it will solve it for you, and essentially you should get an answer which is approximately V1 equals 21.21 with an angle of 45, right? When you enter this in the complex mode of your calculator, you'll directly get this answer, yeah. So we have solved for V1. Now in the same fashion, we solve for V2, right? At V2, you only have two nodes again. We can ignore this, as I previously said. This will be V2 by 6. It's leaving the node, so it is V2 by 6 minus V2 by 6. And you take this section, which is V2 minus minus Vx, and that's divided by 4, right? That's divided by 4. And this is once again equals to 0. Yeah. And then you can simplify this part of the equation as well. What you're going to get, this part is going to be minus 0.16 v2, and this is going to be 0.25 v2 again, and this is going to be plus 0.25 v of x. Yeah, that is equals to 0. When I finally simplify that further, I basically get I'm going to get minus 0.416 v2 and 0.25 v of x equals 0. And solving for v of x, you'll essentially get around 1.6 something v2, right? So you're going to get that equation from the second node. Yeah. Now you know for a fact that v1 and v2 are equal from the first statement, right? Since you know v1 and v2 are equal, since there's no current passing, the potential must be the same, and v2 is nothing but v1, but we know what v1 is equal to. V1 is nothing but this expression, right? So essentially a final answer v of x is equal to 1.6 times 21.21 angle of 45. Yeah, so that is our answer, and you can simplify this further, but this is how you solve it. Now whenever you have any j wala question, you solve it the exact same way you would solve a normal problem. But if you want to simplify it, you can go to the complex mode. If you want to change between rectangular and polar forms, you can either press shift plus plus button, or you can do shift and minus button. Yeah, shift and plus button is going to open the polar window, and shift plus minus will open the rectangular form where you can enter the polar coordinates, and it will convert it to rectangular form. So you solve it the same way. If you have inductance, you solve it the same way you'd solve a resistance. So everything is the same. The only thing is you have to be careful about these conclusions. Otherwise, it's all good, I think. Well, have fun.